We have rectangle ABCD, which has points E, F, G, and H on sides AB, BC, CD, and AD respectively, such that AE equals CG equals 9, EB equals DG equals 5, BF equals DH equals 6, and FC equals AH equals 2. Lines EG and FH intersect at point I. Find the area of quadrilateral DGIH. Pause the video now if you want to solve this problem. So how do we solve this problem? Well, we're going to use a method that's called analytic geometry. Analytic geometry. Basically what this is we take a geometry problem like this right here, and we turn it into a problem on the coordinate plane. And as we know, the coordinate plane, we can turn that into algebra because each line we can write as an equation. So before we get started with solving this problem, we need to know a couple of things. So the first thing is finding the intersection between two lines on a coordinate plane. So let's say I have my coordinate plane right here, and I have line y equals x, so that looks a little bit like this. And then I also have a different line, 2x plus 3, and that looks like that. And I'll go ahead and label this 2x plus 3, so f of x equals to 2x plus 3, and over here is f of x equals x. And if we want to find the point that intersects these two, which is right here, we want to do is we want to set these two equations as equal, because this point right here should satisfy this equation and this equation. So if we set 2x plus 3 equals x, then we subtract x from both sides. We have x plus 3 equals 0, and x equals negative 3. So now we have our x coordinate for this point. So we'll put that down, negative 3. And now we have to find the y coordinate of this point, and what we do is we plug it back into one of these equations. So we'll put it into this one, and f of x equals x, so y equals x, so x equals, or not x, y equals negative 3. And so we know that this point is negative 3 comma negative 3. The other part is we want to learn something called point slope formula. So point slope form for a line. And what that does is, let's say we have a point here, and we have a line that goes through it. It's a crudely drawn line, so I'll get rid of that. We have a line that goes through it, and we want to find the equation for this line. And so how do we do that? Well, let's say this point is a comma b. So this is a comma b. Now the other thing we want to know is the slope of this line. And how do we find the slope of this line? Well, we could have a point c comma d, and we could find the slope by d minus b over c minus a, since it's rise over run. Or we could find it in some other way, but we need to know the slope. So let's say in this line right here, the slope is here. Let me highlight the line real quick. You just redraw that. So I will erase this. Here's our x-axis, our line. So we want to find the equation of this line, and we know we're going to set the rise over run or slope as m. Okay, so now we want to know the equation of the line. Well, the equation is y minus y1 equals m times, in parentheses, x minus x1. Now, m refers to the slope. So here, m is the slope. And y1 would refer to one of these points. Could be that one or that one, just the y-coordinate of a point on this line. And the same with x. So x can be a point on this line, but here's the important thing. Y1 and x1 have to be from the same point. They have to be coordinates of the same point. So now we know this. This is our point slope form, and this is how we find our intersection between two lines. So going up here, we're going to use, again, this is called analytic geometry, and we're going to put this problem onto the coordinate plane. So we're going to graph this on the coordinate plane. I think it's easiest if we go in the top right quadrant. So if we have a plane, we want to use this one because this is all positive coordinates. And what's easiest is I'm going to set this point D right here on the origin, since that'll make our lives easier. So I'm going to go down and draw our coordinate plane. Going to put D right here. So this is D, and that looks like a P. So a D, and point D has a coordinate of 0, 0 since it's at the origin. Okay, now I go back up, and we know that A is 8 units above, since if we measure this, this is 8, 6 plus 2 equals 8, so AD equals 8. And now I want to graph point A, which would be up here, 0, comma 8. And I want to go to point C. C is 14 units to the right of D, so we're going to graph C right here, and C is going to have 14, comma 0 as its coordinate. And now we go to B. B is 8 units above C, so 8 units above C would be 14, comma 8, and that would be B. And now we draw our line, and now we want to put in these points E, F, G, and H because they're on sides A, B, B, C, C, D, and D, A. And you're going to start with E. E is 9 units right of A, so here's A. 9 units right of A would be 9, comma 8, and that would be E. F is 2 units above C, so 2 above C would be 14, comma 2. That's F. And then G is 5 units to the right of D, so here's G down here, 5, comma 0. This is G. And lastly, we have H. H is 6 units above D, so we're gonna draw this as 6 units above, so 0, comma 6. That would be H. And then we draw their lines connecting, and we know that they intersect at I. Now going back to the problem, what it's asking for is the area of this shape DGIH, and I'll highlight it here. So it's this one right here. And if we know the coordinate of I, then it would be much easier to solve for that. So we're going to solve for the coordinates of point I. And how do we solve for that? Well, we know that this point I is the intersection of line FH and EG. And now coming back to our thing, we know how to solve the intersection between 2 points, and now we just need to find the equations of these 2 lines. So how do we find that? Well, we're gonna start with one of these lines. Let's start with FH, and first we need to find the slope because, you know, that's what we need. So how do we find the slope? Well, rise over run. Okay, so I'll set H minus F, so that is 6 minus 2 divided by 0 minus 14. So this is 4, this is 14, negative 14. This would be negative 4 over 14, which is our slope, which we can simplify to negative 2/7. And then we plug one of these points. I will take point H, and we're going to put it into our point slope formula. So right here in point slope formula. And what we do is, we know that's y minus y1 equals mx minus x1. And our x1 in this case is 0, and our y1 is 6. So what we do is y minus 6 is equal to, our slope is negative 2/7, so negative 2/7 x minus 0. And when we simplify that, this turns into y equals negative 2/7 plus 6. So then here's our line. This is our EQN equation of line HF. And then we need to find the equation of line EG. So what is the equation of line EG? We do the same thing again. We find the slope of that line. So the slope would be 8 minus 0 over 9 minus 5. And this equals 2. You can do that math yourself. And then we take one of these points. I'm going to do G, 5, 0. So now you have y minus 0 equals 2 x minus, our x coordinate here is 5, so I'll put in 5. And when we simplify this, this is y equals 2x minus 10. And now we want to find the intersection between these 2 points, because that is where point I is. So if we want to find point I, we set this top equation and this bottom equation equal. So we'll do negative 2/7 x plus 6 is equal to 2x minus 10. And solving for this, so we'll plus 2/7 x plus 2/7 x plus 10 plus 10. What we get is 16 is equal to 2x plus 2/7 x, which is equal to 16/7 x. So we have 16 equals 16/7 x. And we want to find what x equals to. So we're going to multiply by 7 on both sides. Multiply by 7. And then divide it by 16. So you have 16 times 7/16 is equal to x. And 16 cancel, x equals 7. And we plug x equals 7 back into one of these equations. We'll do 2x minus 10. So 2x minus 10 is equal to y. And we have x equals 7, so 2 times 7 minus 10 is equal to 4. And we know now that this coordinate I is 7, 4. And now we know that I is 7, 4, we can solve for the area. And now how do we do that? What I'm going to do is draw a line from I straight down to here, and what this point is going to be is 7, 0. So 7, 0, and we'll call this J, point J. Yeah, point J is at 7, 0. And we can solve for the area of DJIH. We can solve for the area of DJIH pretty easily since it's just a trapezoid. And we know that the area of a trapezoid is base 1 plus base 2 times the height, all divided by 2. And now if we plug it in, we know that, so here is our two bases. Here is base 1, and here is base 2. Base 1 is between D and H, which is 6, and base 2 is between J and I, which is 4. So we plug that into our equation here, 6 plus 4, and we multiply that by our height, which if we scroll up here is 7, since this middle part is 7, 0, and this line right here is 7 long, so we will multiply by 7 and then divide by 2, and this will come out to 35. Now we have the area of our trapezoid. We have to find the area of that blue triangle right here because that isn't part of the shape we want to find. So we will subtract the area of that blue triangle right here, which I've already labeled as 2 by 4. So minus the area of this blue triangle, which is 2 times 4 over 2, which is equal to 4. And now we have 35 minus 4, which is equal to 31. And that is our answer.